Welcome back, class. Thank you for joining me for 6-4. Today we're going to be talking about rational exponents. So in the past, all the way back in the 8th grade, you've known how to deal with whole number exponents. When you square something, when you cube something. We've been reviewing that a lot this chapter. Now we're going to get into rational exponents. And by rational exponents, what I mean is fractional exponents. Now, what I need you to understand first is this little formula here. So, when you're taking the root of a number, essentially what you're doing is you're taking a fractional exponent. You're taking that number to 1 over the root you're talking about. So, for example, when you square root something, that is exactly the same as taking that number to the 1/2 power. When you are cube rooting something, it is exactly the same thing as taking that number to the 1/3 power. When you're taking the 4th root of something, that is exactly the same as taking that number to the 1/4 power. So that's the first thing today that we need to understand is the relationship between roots and exponents. So, what I'd like us to do is these 3 examples. Let's look and see what happens to these numbers. So I have 216 to the 1/3 power. Now we just talked about the 1/3 power is exactly the same thing as the cube root. So what this really does is it gives us the means to type this into the calculator. So once I understand that 216 to the 1/3 power is the same as the cube root, well now I've already taught you how to type that into the calculator. You can type it in and it would give you the number 6. In our next example, so both of those are to the 1/2 power. Well, the 1/2 power is the same thing as a square root. So essentially this is saying the square root of 7 times the square root of 7. Well, we know that that would simplify to the square root of 49. And once again, in root form, we know what this means. The square root of 49 we recognize as 7. All right, for this next one, the 4th root we've said is, or the 1/4 power, we've said is the same thing as a 4th root. So I'm going to consider these as roots. Well, 5 times 125, we know that these combine to 625. And now when I take the root, we know that this simplifies to 5. So that's the first key understanding I need you to have today, is how to convert these fractional exponents into roots. Now, they can get a little bit more complicated than that. All right, so something I want you to understand. We just talked about this rule here. It's nice and easy. When you have a to the 1/2, a to the 1/3, a to the 1/4, really simple. It just turns into that root. However, of course, it can get slightly more complicated than that. What if I have a true fraction, a top and a bottom, like in these next two? Well, what ends up happening? The bottom of your fraction, just like we saw here, the bottom of your fraction becomes the index, becomes the root. The top of your fraction is the exponent that remains on the variable. Or the same thing in this example, it can also be an exponent of the whole thing. So what ends up happening is in these fractions, the top becomes the exponent. The top is your power. The bottom is your root. So let's take a look at what some of these look like. Now, I have here a little diagram. It didn't make it in your notes. So if you'd like to sketch it yourself to help you remember. So here, The bottom number of the fraction. Well, think the bottom of a tree. That's where the roots are. So the bottom of your fraction are your roots, okay, digging into the ground. Then the top of your fraction is your exponent, is your power. Well, think top, think the sunlight that's feeding the tree. Solar energy, power. Okay, so even though it may seem a little bit silly, if that's a little device that can help you remember that the top is your exponent, the bottom is your fraction, or the bottom is your root, please, please use that. Okay, now let's actually get a little bit of practice in here. So x to the 3/7 power. Well, again, we talked about the bottom. The bottom is your root system. So the bottom is your root, your index. The top is your exponent. So that's where the x cubed comes from. And in this example, that's all it's writing you to do. All it's saying is please write in radical form. Well, our next example. Well, we didn't talk about how to deal with decimals. We talked about how to deal with fractions. So the first thing I would do is I would use my calculator to convert that to a fraction. And you will get that that is y to the -7/2. Okay? So, y to the -7/2. Well, hopefully we remember from that concept bite, a negative exponent, that's going to move the whole thing to the denominator. So that whole thing gets moved downstairs. Well, now what do we do? Well, now we have to convert that into radical form. So, how do we convert it to radical form? Oh, I'm sorry. I actually have a typo. Once it's down here, it should be positive now. I apologize. So this should be y to the positive 7/2. Well, the bottom is our root. Well, you can put a 2 there, but it's not quite necessary. It's always assumed to be 2. So you don't necessarily have to put that 2 there. What you do need though, so I have a root of 2, and then the top is your power. So you do need that 7 down there. Okay? So 1 over the square root of y to the 7th. All right, now for this example only, because the instructions only say write in radical form, for this case, I'm actually going to not worry about the fact that there's a radical in the denominator. We could rationalize the denominator. However, for the intents and purposes of what I want you to take away from this, I'm not going to make you do that in this instance. My goal is to get you to see how to write things in radical form. So this is writing that exponent in radical form. So in this instance only, I'm going to move forward and I'm not going to deal with that radical in the denominator. So write the following in the exponential form. So now we're going backwards. Okay, so now we have to reconstruct that fractional exponent. All right, well remember, when it's not written there, the root is assumed to be 2. So the exponent goes on top, and the root is the bottom of my fraction. All right, same thing, even if it's written like this, even if the exponent is around the whole thing and not just the variable, it ends up still working. So I can still say my exponent goes on top and my root goes on the bottom. And so that is how you convert back and forth between these forms. So let's end with our word problem example, and then we will be done with our notes. So our example is on planetary motion. Kepler's third law of orbital motion shows how you can approximate the period p in Earth years it takes a planet to complete one orbit around the sun. Use the function p equals d to the 3 halves, where d is the distance from the planet to the sun in astronomical units. How many Earth years does it take Mars to orbit the sun? Okay, so kind of a wordy word problem. There's a lot there. But however, it's asking for what is the period, so how many years does it take to orbit the sun? Well, so we are looking for P. We're looking for how long is it going to take. Well, you may be wondering, the word problem doesn't actually give us the D. However, over here, if you notice, it does give you that astronomical unit for Mars. So the diagram is actually where we're looking for that value. So we plug that in for D, the distance goes in for D. Now we're looking for the period. We're looking for P. Well, again, in the calculator, we know how to plug in radicals. So that dividing by 2, the bottom of my fraction represents that it is a square root. So the 2 on the bottom of my fraction represents a square root. The top represents my exponent. And you can type that into your calculator. You can square root 1.52 cubed, and when you do, you should get it is approximately 1.87 years. And again, this is one of those times you need to have a calculator in front of you as you're watching this video, because I need you to be checking, can you get that value? Because if you are struggling getting that value, that means you should talk to me in class and we can sort it out together. But if you're not trying, you're not going to know if you know how to type it into the calculator properly. So again, please make sure that you are checking that out, that you're doing that with me as we're taking the notes together. Now, that is actually all for today. So I do thank you for your time. And so what I'd like you to do, make sure you have everything right now, and then bring this back tomorrow, and we will do our practice work together in class.